Hello everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. In this session, I am going to discuss about the implementation of paging technique in operating system. So what is meant by paging and what is meant by page table, what is meant by page replacement, all these concepts we are going to discuss in this topic. So what is meant by paging exactly? So paging is a memory management scheme. So in this out of memory management techniques, there are certain techniques or there certain concepts are there. Paging is one of the most important technique and most important topic also. So here the paging is what? Memory management scheme. It dividing process into fixed sized blocks. So the dividing process, so process or program, whatever it may be, we can say that. So the process is divided into fixed sized blocks. Each and every block will be called as pages. Suppose the process having 4 KB of the size. So the process is dividing into 1 KB, 1 KB, 1 KB, 1 KB. So each and every one will be called as page. Each and every one will be called as page. So these all pages will be load into frames. Load into frames. That is called as paging. It is called as paging process. So here the process is divided into fixed sized blocks called as pages, and the main memory is divided into fixed sized blocks called as frames. So the process is divided into fixed sized blocks called as pages, and the main memory is divided into fixed sized blocks called as frames. Now the process of storing pages into available frames. So these pages are loading into the frames. These pages are loading into the frames, available frames, and using a page table to map logical addresses to physical addresses, reducing external fragmentation process. This entire process is called as what? Paging. This entire process is called as paging. So here the main memory is divided into the blocks, and each and every block will be called as frame. And the secondary memory is divided into the pages. Each and every one will be called as page. So, right. So each and every page is loaded into the block of frame. So each and every page is loaded into the block of frame is called as paging. So here the paging is the process of moving parts of a program called pages from secondary storage into the main memory. Only the thing is we have to move each and every process from the secondary to main memory, and similarly main memory to secondary memory after utilization of the resources. So here the loading of the secondary memory into main memory, each and every process is called as paging. The main idea behind this paging is to break a program into smaller fixed sized blocks. Break a program into smaller fixed sized block. And a process does not have to be allocated in contiguous memory. Process does not have allocated into the contiguous memory, because we have seen that so many allocations, memory allocations for each and every process that must be allocated in the first fit manner or best fit manner or worst fit manner. So here the process does not have to be allocated in contiguous memory space, right? So memory allocation is simplified as memory is always allocated in the fixed sized pages, right? So memory is always available for the fixed sized pages. So how many blocks are available, how many pages are available, so how much the page size is available and how much block size is available. So based on that the pages are loaded into the frames, pages are loaded into the blocks. So here the logical memory is divided into the pages. So logical memory is nothing but it is generated by the CPU. It is generated by the CPU. And physical memory is nothing but it is divided into the frames. So the page table is used to map all these pages to frames. This method eliminates external fragmentation. So we have seen that external fragmentations occurs in the memory allocation process always, right? So fixed sized memory allocations and variable sized memory allocation. In fixed sized allocation, internal fragmentation occur. In variable sized allocations, external fragmentation occurs. So there this entire method is eliminating, this paging method is eliminating this external fragmentation process. So how we are doing this all implementation of this paging technique? So the divide first step is what? Divide logical memory. So how we are dividing that logical memory? That is nothing but the process memory is divided into the fixed sized pages. That is the first process memory is divided into the fixed sized processes or fixed sized pages. And the second one, divide physical memory. So main memory is divided into the frames of the same size. So each and every block is divided in with the same size, that is frames. And create a page table. Create a page table. So OS maintains page table that maps page numbers to the frame number, each and every page with each and every frame number. And then address translation. So CPU generates logical address. CPU generates a logical address. That logical address contains page number as well as offset. Page number as well as offset. We are indicating that page number is with the P and we are indicating that offset is D. And the next process, frame mapping. So page number is used to look up the frame number in the page table. So frame mapping is required. So where the page number is used to look up the frame number in the page table. So out of the entire page table, where the frame number is look up for the page number. And then next, physical address formation. So how we are going to form the physical address? So physical address equals to frame number plus offset. Frame number plus offset. This is the formula to form the physical address formation. So these are all the steps that implements in the to avoiding the external fragmentation in the paging technique. So what is the first one? Divides logical memory. That means process memory divided into fixed size pages, and main memory is divided into fixed size frames or variable size frames, and create page table that maps page numbers to the frame numbers. The next, address translation that generates the CPU logical address which contains page number and offset. And the next, frame mapping, which used to look up the frame number in page table. And last, physical address formation. So how we are doing this all in the paging techniques? So the address structure is what? Logical address and the page number offset. So finally what we have to find? We have to form the physical address equals to frame number plus offset. So from this, the logical address is what? Page number plus offset. We have already seen this logical address where it is address translation occur. The CPU generates logical address which contains page number plus offset. So here the logical address is what? Page number and offset. With this we have to find a physical address. With this we have to find physical address. So physical address formation with frame number and offset. Physical address is formation with the frame number and offset. So here a logical address is the address generated by the CPU. We already said that when program is executed. When program is executed, automatically logical address is generated. That logical address contains this page number and offset, right? So once the CPU generating that logical address which contains both page number and offset. With this we have to form the physical address. With this we have to form the physical address. So if program generator address, this one, page equals to 2, offset equal to 150, right? So page number 2 and offset equal to 150. This is the logical address because it is produced by the CPU, right? Now with this what we have to form? We have to form the physical address. We have to form the physical address. So physical address is the actual address in the main memory. Physical address is the actual address in the main memory. So logical address generated by the CPU which contains page number and offset. With this we have to form the physical address. So physical address is the actual address in the main memory where data or instructions are stored. So if page table gives page 2 to frame 5, then the physical address is like what? Frame comma offset. So logical address lo page number comma offset and physical address lo frame comma offset. This is the actual location of the RAM. Actual location of the RAM. So how to understand this logical address and to understand this physical address, we have to map the paging table. We have to map the paging table. That is why we have seen this, the steps, each and every steps, where the process address divided into the pages, frame memory divided into frames. After that page table creates. We have to create the page table which contains both page numbers and frame numbers. Right, contains both page numbers and frame numbers. Once the page table is ordered, once the page table is organized, the address will be translated as a logical address which contains page number and offset. Similarly, with this formation, physical address will be formed. So from there, where frame is available and where offset is available. So that is the way we have to do this process. So example, if we take an example, the page size is what? 1 KB of the page size, and the process size is what? Total 4 KB of the size. So entire process size is what? 4 KB. Now what we are telling, the dividing entire that process size is into each and every pages. Dividing all that entire process size 4 KB is divided into each and every pages. Each and every page will be having 1 KB of the size. So how many pages are there here? 4 pages are there, because the process size is 4 KB and page size is 1 KB. We are dividing process size into page sizes or pages, is called as pages, but we are loading that all the pages into the frames is called as paging. All these pages loading into the frames is called as paging. So now the physical memory contains frames. Physical memory contains frames from frame number and each and every content. So frame number, and here the page table, page number and page size. Page number and page size. So P0 contain 1 KB, P1, 1 KB, P2, 1 KB, P3, 1 KB. Because the process size 4 KB is divided into each and 4 pages. Divided into 4 pages, right? Similarly, the frames, physical memory frames. So physical memory is nothing but here the main memory. The frame number, frame content. So frame number F0, F1, F2, F3. So how we are loading all these is, suppose the blocks, this is the frame 1, frame 2, frame 3 and a frame 4. So all these frames are having the sizes like 1 KB, 1 KB, 1 KB, 1 KB. So now the each and every process comes to block and how it is allocated. So wherever it is free, it is allocated, right? So in the same way, the F1 contain P1 and F1 contain P3, F2 contain P0, F3 contain P2. So whatever it may be. So where the page is loaded. So P1 is loaded into the frame 0, P3 is loaded into frame 1, P0 is loaded into the frame 2, P2 is loaded into the F3. So this process you can assume as your own, right? So if any particular conditions are applied, then only we can load that page into a particular frame. If no conditions are applied, you can load any of the page into any of the frame, right? So I have done the same thing. Here no condition I am taking. So simply I am loading all the pages into the frames. So according to that, I am loading each and every page. P1 into frame 0, P3 into frame 1, P0 into frame 2, P2 into frame 2, frame 3, right? So now pages are loaded into the frames. Pages are loaded into the frames. So each and every, this is the page table, this is the frame table, and now with this you can see the page table. So according to this, we can create the page table. So page table contains what? Both pages and frames. Both pages and frames. So which page number? So page number P0 is loaded into the F2 according to this scenario. According to this scenario, so page number P1 is loaded into the F0. So P0 is loaded into the F2. Right. So P0 is loaded into F2. According to this scenario, we are loading each and every page into the frames. So P0 is loaded into the frame 2, P1 is loaded into the F0, P2 is loaded into the F3, P3 is loaded into the F1. So if no conditions are occur, we can load any of the page into any of the frames. What we have to do, only the thing is what? We have to create the page table for the page number and page size, and the frames table, frame number and content. And both from these both we can create a page table which contains only page number and frame number. So according to that, we created this page table that contains page number and frame number. So P0 having F2, P1 is in F0, P2 is in F3, P3 is in F1. So now page table is created, right? So now the thing is what? Address translation. Address translation. So what we have to do, the first thing, logical address we have to find. So logical address is what? Page number plus offset. Page number plus offset. So example, logical address, taken any of the page 2, offset 150 we have taken. So how we are taking offset is 150 means for each and every page size is what? 1 KB. So 1 KB is nothing but what? 1024 bytes. 1 KB is nothing but what? 1024 bytes. So 0 to 1023 bytes. Out of these 3 bytes, you can take any of the size. You can take any of the size as a offset size. You can take any of the size is offset size. So now I have taken the page is 2 and the offset is 150. You can take any of the page from these 4 pages. So I have taken only the page 2 for the example purpose. So page equals to 2, offset equal to 150. This 150 you can take from 0 to 1023. Any of the number you can take. And now step 1, page number equals to 2. Step 2, from page to page table, P2 to frame 3. P2 to frame 3. That means, so from the logical address we taken page 2 and offset, right? So logical address contains what? Page number and offset. Similarly, physical address contains what? Frame number and offset. So frame number and offset. So after generating this logical address, the page 2, where this page 2 is loaded, according to this, the page 2 is loaded in frame 3. According to this, the page 2 is loaded into the F3. So now the page 2 is loaded into the F3, I know that, and the offset of the page size is, I know that, 150. Now with this I have to do what? I have to form the physical address. So what is the physical address? Physical address contains a frame and offset size, frame size and offset size. So frame size is nothing but what? Which frame the page 2 is loaded. So which frame the page 2 is loaded means frame 3. So frame 3 plus offset size 150. This will be the physical address formed. Right. So this is the way we can perform this address translation. What are the advantages or disadvantages of doing this all the paging technique? Means the main advantage is what? External fragment, eliminates external fragmentation. And second one is what? Efficient memory utilization. Efficient. So wherever the physical address is identified, there we can see the page size, and according to that we can load the pages into the frame. So that is the main concept. So wherever the size is available, there we have to load the pages into the frame. And it supports virtual memory also. The main disadvantage is what? We can say that eliminating external fragmentation. So in terms of that, we are internally facing the problem on internal fragmentation, obviously, and requires extra memory for the page table also. So this is the way we can perform the paging process. So each and every page contains a page number and page size, right? And each and every frame contains frame number and size. What we have to do, once logical address is generated, which contains page number, offset size will be generated by the CPU. According to this, we have to form the frame, we have to form the physical memory. That is frame, offset, frame plus offset size. So according to this, we have to form the physical address. So once it is formed, there will be the replacing of the pages according to their block sizes. This is the way of understanding each and everything from this paging technique, right? Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.